And so this is like my coming back, teaching for the first time online for like 20 years or so, right? Um, like I find that with this particular set of colors, usually when we start picking it, like two colors are easy to find, right? And then like for some reason, once you get to the third colors, you get like exponentially harder. So I don't know why that is. But one thing that we could do is I could even, I'm going to post this in the group. But what I did was this, like, let's say I have these four colors, by the way. I just kind of picked. I know it's not exact. This is a little bit too. This is actually too dark for this. But one thing that you can try is this, right? With these. Now, so if you look at, everyone can see this in the main screen, right? Like on the big screen, can you guys? Oh,
Yes.
okay, because I don't know what you guys are really seeing, right? So now if you look at these three colors, right?
Yes.
Let's say the color lower intensity. What you want to do is find like a gray that is, oh, you know what? This is too dark. And what you want to do is find a gray that are kind of like a good candidate for it, right? This one might be pretty good. So here's what you want to do. You take these two colors, the highest intensity, and the highest intensity, get as intense as you could, all right? Because to really make the gray feels different, it's going to be, it's going to be, has a very high intensity. So you put the gray, right? Let's say right here, and I think I posted it also. I posted it also online, but just do a demo, right? So you take these two colors, right? You have the gray in the middle, and the dullest color it could be on the outside. So what you want to do is to put this, once you put this up, you need to really move all the way back, right? To like at least 10 feet away. And if you look at that little sliver of color, if it doesn't really begins to, it's not going to look like green, right? But it's going to be, it's not going to look like a neutral gray either. But when you stand back and look at it, if this doesn't pick up a tint, in this case, it will be orange, red. It's like you'll be close to like more like a green, right? But it's not gonna be exactly look like green. It'll just look kind of greenish. So it doesn't work when you're looking at it like this. Then back, then what you want to do is like go one value higher and one value lower, right? And you might find that when you start, moving the value around that one of them, even though the gray might not necessarily be like the same value as the others, like you will find one that will begins to really feel like, like a different hue than like a neutral gray. Does that make sense?
Yeah, that's very helpful.
Okay, right.
I don't think I did that. No.
Yeah, that's fine. I'll take a look at it tonight. Okay. This one is going to be really hard. That's why I kind of like start giving everyone examples. Okay, so
Yeah.
we're going to get started. All right, and see if others might join us. So what we're going to do today is I'm going to do a demo of color transparency, and color transparency. Now, so let's start with like color transparency. Oh, you know what? I should turn on the. Well, this is recording. It should be okay. So in terms of color transparency, there are a few different kinds. You go online and start researching this subject, right? You find that it breaks into three different kinds. The first one is actually what made this particular color experiment, kind of well known, being adopted, was actually from Joseph Albers. And Joseph Albers was the author of this book. This is like the student's edition, like that's a big thick one. That's the teacher's edition. And so he had a kind of color transparencies in there that like he didn't give a particular name, but we're gonna call that maybe like transitional, okay? So transitional, that's referred to like the Albers kind, and the value is different. Then what we are doing is more like a subtractive kind of color transparencies. And later, as I lay these out, we'll talk about the difference between them, okay? So what we're doing is actually trying to create the feeling of overlapping acetate. And so let's say you, I'm going to take these two colors, okay? So let's say we were blue, and let's say this, like, as long as it's not a glare, it's a little bit of a glare, but otherwise it'd be too dark, okay? Yeah, that's a small glade. Yeah. So if I look at the blue and then I look at the yellow, and it shouldn't really matter that much which one is overlapping which one, although these are not completely translucent, they are a little bit cloudy. Now, so when you look at these two colors, right? Yellow and blue gives you, what hue is that?
Green.
Green, right? It's just like your color wheel, right? So if it's not green, we'll have to like go back to the drawing board, right? So yeah, it's green. So it's just like in your color wheel. Now let's say if I have okay, let's say if I have blue and green, what should that give us?
A blue green. I mean,
Yeah, yeah, that's right. It wasn't a trick question. You're right. So it's a blue green, right? So you know, so blue and green give us blue green. And let's say we take blue and red. You know, as you can see, that gives us purple, right? So in terms of color transparencies, that's the first thing to keep in mind, okay? As a kind of checklist. The first thing is this: when you have two colors, you know, that overlay each other, two transparent colors, then the middle color is always as if, you know, how you did it in your color wheel, right? And it follows, you know, the LS, you know, HSL kind of model, the red, yellow, and blue. So you can always kind of predict that. So that's the first thing we know about hue. And you know what? And then red and yellow. You know, would give us kind of like an orange, right? Although you know what, in this case, the yellow is a bit cloudy, so let me slide that down. Now I know the color effect is very subtle, but as you can see, what it actually give us is that the yellow and the red, and it's gonna be hard to see, is that this is actually like an orangey kind of color, right? Now from your screen, it probably look just a little bit more orangey than this color, right? So it's like the effect is actually very slight. Certainly, it's not as pronounced as if I look at the green, the violet, and the blue-green. So there you have it. You have like basically you have the three primary colors together, and yeah, okay. So now, so that's the first thing that we know about hue. The second thing we know about hue is this. If you look at the hue of, let's say, this color and this color, now, so I'm going to introduce like terminology. And actually last night what I was doing is I went online to really start looking into like, what do people actually call this? I know what that was called in the Elber's book, and I know how I would talk about it. And then it seems like the language that people use in this particular color experiment came right out of Joseph Albers. So let's call these sheets the parent colors, okay? And let's call this the child color. So these are the two parents, or these are the two parents in which they're single layers of color acetate, and that's the child color. So this is actually born from these two, so I guess it makes sense. And so we're gonna adopt that language. So now, so we know about hue. Now we can actually know about hue more specifically. So I say when you look at the hue of the child color, this is actually closer to this hue than to this hue, right? So when you look at this color, you'll find that the hue of this color leans to the blue side. If you look at the hue of this color, you will see that the hue of this color, the orange, is actually closer to the red than to the yellow, than the two parent colors that produce it. And in this case, well, I mean, when I look at the blue and the green, as the parent colors, the child colors, or where the overlapping area is closer to the hue of this than it is to this, right? So the reason for that is this: you'll find that when you look, it's like paints, right? When you're mixing paints, and I know, remember when we did the color wheel, like a big issue, you know, I think for a lot of you, is that the colors are just the tinting strings, are just so lopsided. like your red, a lot stronger than the yellow. So now, so when you look at these colors, you find that the hue of this is always going to lean to the darker color. So between this and this, the blue is darker than the yellow. Therefore, the hue of the child colors produced by these two will be closer to the blue. So it's not just green, but it's actually kind of like green slightly to the blue side. And I'm looking at the screen, it seems like from your perspective, it should look really blue. So in here, like between this color, so the hue leans toward this. Between this color and this color, the hue of this lean towards this. Because again, this is a darker color. And it's like the most drastic case here, where this is closer to this than it is to this. The two parent colors, the child colors always lean to the red side. Does that make sense? Right.
Yes.
Okay, good. Yeah. So yeah, feel free to ask questions. So the hue is always going to lean to the dark side. So that's actually two things that we know about hue. So when you're doing this assignment, those are the two things that you need to keep in mind with the hue. Number one is always as if the two colors that produce it, the two parent colors. And number two, the hue will always lean to the dark side. So we know that from the get-go, right? So that's what we know about hue. Now let's go to the value. And this is, I noticed, is that when I kind of like previously when I teach this class in like a real classroom, this seems to be the one that really stumped a lot of people, which is this. If you look at while the hue of the child colors always lean to the dark of the parent colors, and it's always as if you're mixing the paints together. If you look at the value, you'll notice that between A, B, and C, C is darker than A and B. In other words, that when you're figuring out the color transparency, just keep in mind that the hue of the child colors is going to be closer to, it's going to be darker than the two parent colors that produce it. The value is always between these two. So this is darker than this and darker than this, just like right here. This is darker than this, and this is darker than this. And then in here, although might be, I'm looking at the screen, you can still see it, which is that this color is darker than not just this color, but it's darker than this color. So while the hue is always between these two, the value is always darker than the two colors that produce it. Does that make sense?
Yes.
Yeah. Okay, good. So that's what we know about value. So one way for this to make sense is this. We are working with acetate or transparent films, right? So imagine if you have, for example, let's say if I just take blue, right? Let's say if this is one layer of blue, which we have in here, and let's say I'm going to overlay another blue, right? So it's going to be darker because the white of the table is being subtracted by this value of the blue twice, once and second. Similarly, when you look at these two colors, like this is subtracting from the table once, this is subtracting from the table again, whereas this is accumulating how these two colors are being subtracted from the white surface. So when you're making the assignment, when you're doing the assignment, just keep that in mind. Again, that's the part that really is kind of jarring, okay? So we know that about value. That's the first thing. The second thing we know about value is this. If you look at all these colors, right, you might notice that this is a little bit darker than this, a bit more darker than this. This is darker than this, and this similar in here. But when you look at this color, you'll notice that when you look at this color, it's quite a bit darker than the other ones, right? So when you look at these, even though, if you think about it, even though when you look at these two colors and they're both really dark, this is still a little bit lighter than this, right? So when you look at these two, they're being overlapped by one sheet of blue acetate. by these two pieces, but you can see that this is actually quite a bit darker than the other ones. So this is the subtractive colors at work. And if I remember correctly, yeah, I think that in the Munsell talk, I also talk about this, which is that when you look at, yeah, specific about that point, when you remember Munsell talk, I mentioned that if you look at the red and you look at the blue, let me start on the, let me see if I can find a color wheel. I think I have a color wheel in here. Okay. Kind of small. Okay, you know what? Let's use this one then. It's kind of small though. So if you look at the color wheel, and this is your experience with doing it, which is that you take the red and you take the blue and you mix them together, and the violet is quite a bit, you know, darker than the two colors that produce it, right? So that's an example of subtractive colors at work, which is this. Along the color wheel in all these areas, you know, like this is roughly in the middle value of this is roughly in the middle value of this, and so forth. But the violet is actually quite a bit darker than the two areas that produce it. So that's really just a kind of idiosyncrasy in color theory. And that's just an example of subtractive colors at work. So another clear example of subtractive color at work, which I went into in the Munsell talk, you know, rather substantially, is that opposite colors are going to cancel each other out, right? So, when you're doing the color wheel, I don't know if I mentioned that there's actually a way to prove if your secondary colors are correct or not. And the way that you do it, let's say if you the green, you're not really sure if the green is correct, you mix it to the red. So once you mix it to the red, if the two colors are correct, you get a color that's very close to black, right? So that's how you can tell, like, because colors subtract from each other. Light is different. RGB, the three different kinds of light, you mix them together, you get white. In a subtractive color world, which is mostly the world that we live in, red, yellow, and blue mixed together in the right balance would create black, right? Or something very, very close to black. So that's subtractive colors at work. So what you see in here, that the red and the blue gives you a color that is quite a bit darker than any of these other mixture, is a clear example of subtractive colors at work. And another example is this, red and green. So let's see. I don't know, actually. Let's see how far this goes. Here's the green. And here's the red. Okay. Hey, what do you see? What color do you see on your screen?
Looks kind of red.
It's kind of red, right? But
yeah, it's a very dark red.
Yeah, it's very dark red. It's not exactly black, but it's pretty close to it, right? So you know what I'm going to do? I'm just going to take some paper. And we'll just isolate this area to see how black that is. Okay, so it's like it's a very dark red, close to a black. So now what I'm going to do is I'm going to take these out, and I'm just going to slide this down again. So you see what happened to this color as it enters here, right? It becomes a darker version of this color because the green is canceling out the red. The reason, I think in this case, when you look at these two colors, and the value of these two are actually pretty close. This is actually a little bit lighter than this, at least as I'm looking at the computer screen. In real life, this is lighter, not a whole lot. So the reason it leans to the red side is red, yellow, and blue gives you black. If this is red, this green actually have to work kind of overtime because to create black, it needs to function both as yellow and as blue. So in this instance, because we only have this one color to stand for yellow and blue, and here just is for red, is why they don't really kind of cancel each other out, and the colors lean to the red side a little bit. So we could see if we actually could create a black from it. To get like a real black is going to be really the color needs to be exact. Huh. Well, not 2 layers of green. Hey, what do you think? What's the middle color? Is it leaning to the green side or is it leaning to the red side? Hmm? To the green side or to the red side? Anyone?
Either green or it looks really black to me here. I mean, maybe not as black as when you surrounded with the white, but I don't see the hint of green as much.
No, just whoever invented this acetate didn't really think about it as using as a demo. It's just a stationary supplies. Let's see. Oh,
Okay, green. It was leaning to green.
Right, you're right. Hey, good eye. Oh, yes, leaning a little bit to the green. But it's only closer to a black than it was before, right? So this is what happens with subtractive colors as well. So that's the second things we know about value. Other than that, the child colors is always going to be darker than the parent color. Now we know that when we're figuring out the colors in the middle, it's actually, it's like follow a kind of like the subtractive kind of color effect, in which when you take two opposite colors, you get something close to black. And if you take red and blue, you get something a little bit darker than the other colors. Does that make sense? Right? Yeah.
Yeah.
Okay, you know what? So we know 4 things already. So now I'm going to do is I'm going to take the red. And oh, you know what? I have an idea. So you take this, and I'm going to take this with, you know what? I'm just going to take this and this, okay? And then I'm going to take this in here. And so one thing that you'll find is this. If you look at these 2 colors with this color, so now it's an instant in which you don't have subtractive colors in work. When that is the case, you'll find that the value tends to be very consistent, which is this. If this is lighter than this, then this will be lighter than this, right? So you can always, unless you have something going on that is subtractive colors, you can always assume that if you have 2 pieces of acetate on top of a yellow one, that whatever value that is between the 2 parent colors would actually reflect in the child colors as well. So that's something that you can also tell. Here's an example. Blue and blue is going to give you a dark blue. And as you can see, because this is lighter than this is therefore lighter than this. Does that make sense?
Yeah.
Yeah. Color is very logical. I mean, that's probably something that you would, could see by now. Like this, when it comes to color, there's almost no accident. It's just, I think, when people before studying color theory, the whole thing is just very mysterious to them. But once you begin to put all the pieces together, you would realize that in color theory, there's no accident, no surprises, and it's very predictable. Okay. All right, so now we know 5 things. We know 2 things about hue. We know 2 things about value, or rather 3 things, because the last had to do with subtractive color. So that's all we know about those 4 factors. So what do you think if we take color A paper? Do you think we can just duplicate the effect that we just did? Is it doable, you think?
Like with our color aids? No, I don't think so.
Well, we're gonna try, okay? That's
All right.
the assignment, okay? So, but let's see. You're not gonna get exact, but you get something very close. I'm gonna take this. And let's say yellow, right? Let's say one of the parent colors yellow. Let's say the other one is red. You know what? This might be easier. I'll take this red. So what you want to do when you're thinking about these overlapping, acetate, is that the colors or the parent colors are going to be, you know, fairly light because you have to consider that the white of the table is coming through. So I'm going to take these two colors and, well, you can see, well, this is actually, that's almost the same value as this. This is the same value as this. This is lighter than this. If you take these two colors together, here's what we do know. This is red, this is yellow. We know the hue is going to be orange. What we talk about, the first thing we know. We know that the orange is going to be closer to the red than to the yellow because the red is darker than the yellow. So what we need is actually an orange that is not going to be exactly orange, but it's going to be more like a reddish orange. Imagine these are acetate that they overlap. So those two things we know. We also know that the value is going to be darker than both of these colors. So what we're really looking for is not an orange, but a reddish orange because of the darkness of this. And we're looking at a value that's darker than both of them. Now, so what you want to do is this. With these assignments, what you want to do, I just picked this out, my air conditioner is been on. So when you take these out, like hopefully it's not like mine, which is all curly, right? So I'm going to take this and I'm going to take this and I'm going to take, I sorted out some of these earlier. Let's see. Yeah. Well, this is not going to work. It's like sort of. This is actually the two values are too similar. This maybe too dark. Let's see. So when you're testing these colors out, it's important that you test them in the configuration that I'm showing you, which is you're going to look at the long side, you're going to look at the short side, and what you want to do to test the colors is to put them like this, okay? So if I'm taking this, I'm taking this, what you want to do is, you don't want to do them like this because that's not going to work, right? You just like 3 bands of color. So what you want to do is always have a short side and a long side. And then imagine if this goes into here. Yeah, hopefully you when you do it, it's not as curly. So what you want to do is like once you lay them out, and then you look straight down at it, and ask yourself, can you imagine that these are overlapping transparent film, right? So I look at this, it's not bad. The only thing I don't like is this. I'm looking at these two colors, and true, this is darker than these two. The hue feels pretty good. It's just that when I'm looking at from the table to here, this is just a little bit darker than this. This is darker than this from a bigger margin. So I'm going to try, my pack is not, you know, like my pack is actually, I've used it quite a bit already. But let's see. You know what I'm going to do? I don't think I can find a lighter version of this. I'm going to try a darker version of this. Let me see. Ooh, let's see if there's something in between. Nope, that's it. So it's either this light or this dark. It feels okay because this is darker. This should actually have a little bit more red to it because we know the hue is going to lean to this. I feel like I can see enough yellow almost as if it's sliding underneath the red piece of acetate or transparencies. You know, imagine this is transparencies. I feel that it's like, to my eyes, it's more believable, you know, than what I had earlier. It's not perfect. And I'm looking at these colors. I might not be able to find an orange that is just right. But now you can actually, you see the drill. Like you try to change the middle color. If you can't find it, then you fix this one and you fix this one, right? Does that make sense?
Mm-hmm.
Yeah,
Yeah.
that's how you go about it procedurally. On the other side, so what you want to do is when you're doing this, don't try to make them perfect. You won't be able to do that from the get-go. What we're trying to do is to create a color transparency that will involve 4 child colors, okay? 4 of them. So there should be 4 of the overlapping area. So what you want to do after you've done this is maybe go to the next one. And let's say if I have yellow and yellow and blue green. If I can find a good one. Not bad. Let's see. So now, when I'm going to test out the other side, seeing that this is the short, so this is important because it seems I feel like when I'm teaching this class, you know, face to face, there's always the issue in which the configuration is incorrect. So if you take this and this, now what you want to do is like turn this way, put it right here, and then let's say this is yellow, this is blue-green, but this is so much darker than this. So I'm going to try this one then, because this looks more yellowish than this, and I think it's darker than it. Let me see. Oh yeah, you know what? Let's see. So when you do this, it's good if you flatten up the color paper. And then what you want to do is look straight down and then use your imagination and ask yourself, is it believable that if this is a piece of transparency, this is another one, that this is actually where they overlap? And it looks to me that this side is pretty good. I think it's more successful than this side just because the value is right. I mean, I feel that, see, the only area that strikes me as off is this. When I'm looking at these two colors, like this is just a breath, at least like when I'm looking, maybe different in camera. When I'm looking, this is a little bit lighter than this, and yet this is a little bit darker than this. So what this does is affirm what I thought earlier, which is that this color is too light, which is also why you shouldn't try to make this perfect. What you want to do is like now you have two child colors, A and B. So what you want to do maybe from there, you build another one. Let's say yellow and yellow give you a darker yellow, right? Or you can build from here, you can say red and red violet gives you violet, or red and blue gives you violet, depending on the value of the violet. So now you've built two, and you know you should just do this. Like, don't need to really kind of linger on too much. From here, you go to the third one, and you go to the fourth one. So altogether, you have 1, 2, 3, and 4 child colors. When you're doing that, you might find if these two aren't working, let's say in here, you might need to adjust this color. So if you adjust this color, then you need to adjust this color, because if this is darker, then this would be darker and more to darker, and maybe a little bit more to like the yellow side if this is darker. So so you'll find that sometimes if you can find a good or perfect child color, you work on the parent colors. And when you work on the parent colors, you might actually need to adjust the other color transparencies again. So basically what you'll be doing is kind of your problem solving color. Does that make sense?
Mm-hmm.
You think that's doable? Sure. Okay. Yes. Yeah, it's definitely doable.
It may be hard with like the amount of colors that we have left in our pack, maybe. I don't know.
No, yeah. No, this is like, so as I mentioned, like that's part of actually of this, is that you're problem solving. So you need to like, you can't find the best candidate, you find another one. And then it's really through that process of having to problem solve a finite set of colors that you actually begin to kind of challenge yourself very differently than if you say you're using paint. So, so if you want, as you keep working on this, you can always post that and then I'll look at it, okay? And then what I'll do is, okay, so work out. So once you work these out, right, from the short end going to the long end, again, that's really important because I do see students like going the short end to short end or long end to the long end, or they don't really line up, so that's not going to work. And as you're doing this, you just look at it and you just use your imagination. I teach also at Pratt, and I actually have a colleague who was a student there, and he's a fellow faculty. And he mentioned when he was doing this in the middle of the night, he said, while doing this, like there was a moment, I guess he was like really, you know, like our student, they work until the middle of the night, that when he looked at it, he thought he thought his own color transparency was so successful that at one point he thought that they must be, you know, color acetate. And you have to lift it up to kind of reminds himself that it's color A paper and it's opaque. Okay, that's it. I think, right, so I think I covered all 5 points. Any question before we go? We're good. Okay. Good luck. This is our last assignment, okay?
Thank you.
Thank you.
Thank you.
Right.
Thank you.
Take care.